This is the second video where we're talking about the words used to describe motion. Today we're going to focus particularly on acceleration. So acceleration is a vector quantity, so it does have a number and a direction. And acceleration specifically refers to the rate at which an object changes its velocity. Remember, velocity is speed in a particular direction, and so a change in speed or a change in the direction or both changes will result in acceleration. Unlike acceleration's use in sort of common language, when we're in physics, when we talk about acceleration, we are not talking about going fast. That's our common understanding. But in physics, we're talking about this change in speed or direction, this change in velocity. So that any time an object is changing velocity, it is accelerating. This little illustration gives you some ideas where you can be accelerating because you're speeding up. So you're changing your speed, or you can accelerate because you're slowing down, because again, you're changing your speed, or you can accelerate because you're just changing directions, like going around a corner, keeping a constant speed. The fact that you're turning, if you're driving your car, for example, you are still accelerating. We're talking from the physics use of the word. When it comes to acceleration, there's basically two different states. You can have constant acceleration, and constant, remember, means that things are not changing. In constant acceleration, the velocity changes by the same amount for each time unit, whether you're measuring it in seconds or minutes or hours. Over that same time unit, you get the same amount of velocity change. So this first table gives you an example of a constant velocity, whereas each second you see the velocity adding 4. So it's 4 more from 4 to 8 plus 4. 8 plus 4 is 12. 12 plus 4 is 16. So this constant, repetitive, same change over each 1 second time interval, 1 to 2, 2 to 3, etc., would be considered a constant velocity, or constant acceleration, sorry. Whereas a changing acceleration occurs when the velocity is different every time unit. It's not having the same amount of increase every time. So in this case, again, we're going seconds, 0, 1, 2, 3, 4, every 1 second. But the first time we're going change of 1, then we have plus 3, then there's plus 2, and then we've got plus 2 again. And so this is a non-constant acceleration, or a changing acceleration. Most of our calculations that we'll do in class have to do with figuring out an average acceleration. So our average acceleration is calculated by dividing the change in velocity by the time interval being considered. And in order to calculate the change in velocity, you take the final velocity and subtract from it your initial velocity. So in a formula form, this little delta sign means changing, so the change of velocity over time, or the velocity final minus the velocity initial. Acceleration units contain 2 time values because there's a time value in our velocity reading. Remember, velocity is speed with a direction, and speed would be distance divided by time. And then that whole thing is also then divided by time. And that's why we end up with units such as meters per second or kilometers per hour per second. If both units are the same, then instead of doing like per second, meters per second, we can just say meters over seconds squared. So let's look at this example to see what's going on. If you want to apply this figuring out the average velocity. So if you drop an object, it's going to be in free fall. And as it falls, every second that it falls, it is going to be having an increasing velocity. So for starting at 0, that first second, by the end of the first second, it is traveling at a speed or a velocity of 10 meters per second in a downward direction. At the end of the second, it is traveling at a velocity of 20 meters per second. So what's our acceleration that's happening between seconds 1 and 2? So we're trying to figure out, what's our average acceleration here. We take our final velocity of 20, subtract our initial velocity of 10, from it. We put it over the time, which is 1 second. So this is the meters per second, and this is 1 second. And then, of course, 20 minus 10 is 10. And so our answer would be 10 meters per second over second. And just the math to just show you how you end up with squares, the fraction bar, when you divide fractions, you multiply by the reciprocal. So you're actually doing 10 meters per second times 1 over a second, because this is a like a whole number 1, and then we turn it into a fraction. We make it its reciprocal, and that's how we get our 10 meters per second squared. So that's how you end up with those squared units when they're actually the same. Here's another example. A peregrine falcon accelerates from 0 meters per second to 80 meters per second in a 4-second interval. So what is the average acceleration? So again, we take our final velocity. So we have 80 meters per second. We don't have a direction here, but we'll kind of assume it's got to be in some downward direction if it's in a dive. Subtract from that our initial velocity, which was, not traveling downward at all. So 0 meters per second, and then it's over a 4-second interval. Do the math, 80 minus 0, that's easy. 80 then divided by 4 would be 20 meters per second. And then again, since we're over seconds, it's going to be seconds squared. So that's how you calculate an average acceleration once you know your final and initial velocities. And the final little piece for acceleration that I want to talk about is the direction of acceleration. So in order to determine if the overall motion of the object is one that is speeding up or slowing down, you consider the direction of motion of the object and the direction of acceleration. If both of these directions are pointing the same way, then the object is speeding up. And it doesn't matter whether the arrows are going to the right or going to the left. In both cases, the motion object, the velocity, direction of velocity, and the direction of acceleration is the same. And then the end result will be that this object, whatever it is speeding up. And then if it's opposite, if they're pointing in opposite directions, that is a clue that the object is slowing down. And again, it doesn't matter whether the velocity is pointing right or left or the acceleration is pointing right or left. The key thing is that they are pointing in opposite directions, and that's the clue that this object in motion is actually slowing down. So that's all I have to say about acceleration. This is a short little video, but just to check your understanding, can you explain what acceleration is and, of course, what it is not, because it is a word that gets used outside of physics and you might have some wrong understandings. Can you distinguish between what constant or changing acceleration means? Do you know how to calculate the average acceleration? And can you use the direction of motion and acceleration to determine if the object is speeding up or slowing down?